Hello friends, now we are going to solve numerical 2 based on fault analysis. So the given question is at a 220 kV substation of a power system, it is given that the three-phase fault level is 4000 MVA and SLG fault level is 5000 MVA. Neglecting the resistance and capacitance of the system, the first question is, this is linked question. First question is the positive sequence driving point reactance of the bus is A 2.5 ohm, B 4.033 ohm, C 5.5 ohm and D 12.1 ohm. And the second question is the zero sequence driving point reactance of the bus is A 2.2 ohm, 4.84, 18.18, 22.72 ohm. This is the question. Now the positive sequence driving point reactance of the bus is. So the first question is asking what will the value of Z1. So how we will calculate? We have been given the three-phase fault level is 4000 MVA and we know that short circuit power is equal to base power into 1 upon ZPU. So what we are going to do is we are going to first find out the value of ISC in case of three phase. So we know the formula. We know that S is equal to root 3 times of VL into IL. So S has been given as 4000 MVA, short circuit MVA has been given as 4000 MVA. This will be, if this will be short circuit, then here it will also be short circuit. This LL I have been written for line purpose. So short circuit power has been given as 4000 MVA. 4000 into 10 to the power 6 is equal to root 3 into VL has been given as 220 kV. So 220 into 10 to the power 3 into ISC of 3 phase. So we can calculate ISC of 3 phase from here, that is equal to 10,497.27 ampere. So ISC we have calculated and we know the formula. ISC will be equal to voltage upon Z1 and we know that this will be in per phase. Always remember, if this kind of fault was there when it was a voltage and here was an impedance and short circuit. So ISC directly we calculated EF upon Z. So here EF has not been given, it has been given the voltage. So now what we can do is ISC will be equal to V upon Z1 and always remember this V should be in per phase because whatever the value we have calculated, this is line and phase, both are equal. So if we are applying in this formula, Z1 is per phase, so we should be also in per phase. So ISC we have calculated 10497.27 ampere is equal to 220 upon root 3 into 10 to the power 3 upon Z1. So from here we can obtain the value of Z1 is equal to 12.1 ohm. So this is the answer of the first question. Now I am going to solve for the second question. What will be the zero sequence driving point reactance of the bus? SLG fault level has been also given as 5000 MVA. So short circuit MVA of SLG is equal to root 3 times of VL into ISC of SLG. So 5000 into 10 to the power 6 is equal to root 3 into VL means 220 into 10 to the power 3 into ISC of SLG. So here if you want to calculate the value of ISC of SLG, so ISC of SLG is coming out to be 13121.59 ampere. So we calculated the value of ISC and we know the formula of ISC of SLG. Guys, always remember here it will be 3 into IR1 fault current. So IR1 value is 1 ER upon Z1 plus Z2 plus Z0, and this ER will be in per phase, because you know on the denominator Z1, Z2 and Z0 are in per phase, and we know that this will be line and phase. This we have calculated, either we'll calculate in line or phase, this will be equal. So putting the value 132121.59 is equal to 3 into ER, means 220 upon root 3 into 10 to the power 3 upon Z1 value has been given as, we have calculated the value of Z1, and that is 12.1, and we know that in general Z1 is equal to Z2, so plus 12.1 plus Z0. So we can calculate Z0 here, that is coming out to be 4.4 ohm, 4.84 ohm. So here it is all about this, all this question. Thank you.